The hybridization in regular molecules we already learned in our regular classes. And see here in competitive exams like JEE and NEET, they never ask you direct questions. See here they will ask the hybridization in different cations and anions. And you know one thing, there is a trick to find out the hybridization and shape of the molecules of cations and anions. And in this class we are going to discuss how to find out hybridization and shape of the molecule of few cations and anions. To find the hybridization of a molecule and shape of the molecule, we have a shortcut. It's nothing but the formula to find out hybridization number. See here, number of valence electrons plus number of monovalent side atoms minus number of cations plus number of anions by 2 gives the hybridization number. Okay, and see here, it gives hybridization number. That hybridization number gives us the type of hybridization and shape of the molecule. Let us check with a few examples. Let us say beryllium chloride. Beryllium chloride. What is the central atom here? The central atom in beryllium chloride is beryllium. And how many valence electrons are there around beryllium? There are 2 valence electrons. Okay, let us substitute the values. 2 plus number of monovalent side atoms. All halogens are monovalent. Okay, and see here there are 2 chlorines. I am writing 2 here minus, it is a neutral one, there is no cation, there is no anion, no positive and negative charges. That's why 0 plus 0 by 2. 2 plus 2 4, 4 by 2, that is equal to 2. If hybridization number is 2, it is sp hybridization. Okay, if hybridization number is 2, then it is sp hybridization. sp hybridization means what is the shape of the molecule? The shape of the molecule in case of sp hybridization, linear. If the shape of the molecule is linear, what is the bond angle? Bond angle is 180 degrees. Okay, from this hybridization number we can find all these things. Okay, let us take a few more examples. Boron trifluoride. In case of boron trifluoride, the central atom is boron. How many valence electrons are there? Boron belongs to third A group. That's why third A group is also called boron family. Okay, and in case of boron trifluoride, the central atom is boron. Number of valence electrons 3. Number of monovalent side atoms, there are 3 because the halogens are monovalent. Fluorine is halogen here. Minus, it is a neutral atom, there is no positive or negative charges, that's why I am writing 0 plus 0 by 2, that is equal to 6 by 2. 6 by 2 is equal to 3. See here, if hybridization number is equal to 3, it is sp2 hybridization. sp2, 1 plus 2, 3. 1 plus 2, 3. sp2 hybridization. If it is sp2 hybridization, what is the shape of the molecule? The shape of the molecule is a trigonal planar. Trigonal planar. And bond angle is 120 degrees. We will discuss more about these bond angles and shapes in VSEPR theory, valence shell electron pair repulsion theory. Okay, now you just focus on how to find hybridization number. Based on hybridization number, how to find hybridization shape and bond angle. Clear? Methane. Methane is the simplest hydrocarbon. Out of millions of hydrocarbons, the simplest one is methane and its formula is CH4, 1 carbon hydrocarbon. See here, in case of methane, what is the central atom? The central atom is carbon. See here, how to find hybridization number? Number of valence electrons in carbon, that is 4, plus number of monovalent side atoms, there are 4 monovalent because hydrogen is monovalent. See here, there is no positive charges and negative charges, that's why I am writing 0 plus 0 by 2. 4 plus 4, 8. 8 by 2 is equal to 4. If hybridization number is 4, then it is sp3 hybridization. sp3, total 4. Okay, 1 sp3, that is 4 here. sp3 hybridization. If the molecule with sp3 hybridization, what is the shape? Tetrahedral shape. Tetrahedral shape, and bond angle is 109 degrees 28 minutes. 109 degrees 28 minutes. Why minutes came here? 1 degree is equal to 60 minutes. 1 degree is equal to 60 minutes. 109 degrees 28 minutes. Let us check the hybridization and shape of the molecules of few given examples on the board. Okay, let us check. First we will start with NH4 plus. What is NH4 plus? It is nothing but ammonium ion. See here, what is the number of valence electrons here? Number of valence electrons in case of nitrogen. Nitrogen has 5 valence electrons plus there are 4 monovalent side atoms. Minus, there is a cation, I am writing 1. There is no anions, 0 by 2. That is equal to 4 minus 1, 3. 5 plus 3, 8. By 2 is equal to 4. Then it is sp3 hybridization. sp3 hybridization, and shape is tetrahedral. Shape is tetrahedral and bond angle is 109 degrees 28 minutes. Clear? Now next one, NO3 minus. In case of NO3 minus, the central atom is nitrogen, number of valence electrons of 5, and here oxygen is not monovalent, that's why I am writing 0 here. Minus, there is no cation, and here there is 1 negative charge, I am writing plus 1 here. By 2, that is equal to 5 plus 1, 6. 6 by 2 is equal to 3. If it is 3, then it is sp2 hybridization, and shape of the molecule is trigonal planar with bond angle 120 degrees. Clear? Next one, SCl4, sulfur tetrachloride. And see here, how many valence electrons are there in case of sulfur? There are 6 valence electrons and 4 monovalent side atoms. Minus, there is no positive or negative charges. Then it is equal to 10 by 2. 10 by 2 in the sense 5. The hybridization is sp3d. sp3d. If it is sp3d, what is the shape? The shape is, expected shape is trigonal bipyramidal. But here, how many side atoms are there? Only 4 side atoms are there. sp3d hybridization with 4 side atoms, central atom with 4 side atoms, it shows the shape of the molecule as a seesaw shape. What is the shape? Seesaw shape. In parks, in children parks you will observe seesaw. 2 kids are sitting on either side and they are swinging like this. Okay, that is seesaw. Seesaw shape molecule. Okay, ma'am. And next one, xenon tetrafluoride. How many valence electrons are there in case of xenon tetrafluoride? Xenon 8 electrons are there plus, and fluorine 4 monovalent, minus, no cations, no anions, by 2, that is equal to 8 plus 4, 12. 12 by 2, that is equal to 6. If it is 6, what is the shape? The shape of the molecule is octahedral shape. But here there are no 6 side atoms, it has only 4 side atoms. sp3d2 with expected shape octahedral having only 4 side atoms is square planar. 4 hybrid orbitals, they will arrange like this. Okay, square planar. And next one, ClO3 minus. In case of ClO3 minus, what is the central atom? Chlorine. How many valence electrons are there in case of chlorine? 7 are there. And oxygen is not monovalent, it is divalent. That's why I am writing 0 here. Minus, there is no cation. 0 plus, there is 1 negative charge, minus 1. That's why here I am writing 1 negative charge is there. No, that's why 1 by 2. 7 plus 1, 8. 8 by 2, 4. 4 in the sense, what is the hybridization? sp3 hybridization. sp3 hybridization with 3 side atoms is pyramidal shape. Okay. If there are 4 side atoms in case of sp3 hybridization, tetrahedral. If there are only 3 side atoms, then it is pyramidal shape. One more example, ammonia. We already learned that one. And see here, please check all these examples. It is very important, interesting shortcut to find out type of hybridization and the type of the shape of the molecule, bond angles and all these things we can find out, even though they are positively charged cations or negatively charged anions. If you know this formula to find out, it is easy to calculate and it is very important to manage the time in competitive exams. Please take care.